Bom dia a todos e todas. É um prazer recebê-los aqui em nome do PFC Brasil e do PFC Internacional. Seguiremos agora em inglês com uma tradução simultânea, porque é também um prazer para nós termos participantes de vários lugares do mundo. Para aqueles que não nos conhecem, and for those that don't know who is PFC, PFC is an international non-profit and non-governmental organization established in 1999. We are a third-party certification of forest products organization. We promote sustainable forest management through independent third-party certification. That's what we do. We set standards for sustainable forest management and chain of custody. Our standards have a specific focus on enabling smallholders to obtain certification. Our eco-label enables business and consumers to identify products from sustainability management forests. Next. Next one. We certify all process. We go from forest to end user. When we are talking about sustainable forest management certification, we are talking about responsible and sustainable management. We are talking about maintaining and enhancing value of the forest. When we move through the whole chain, we want to assure legality, responsible source, and traceability. Next. Next. PFC is a global supply. As you can see on the map, we are present, we are all over the world. So if you want to find supply in the US or Australia, you can count on PFC. Next. And why sustainable forest management matters? This is very important. When we are talking about forest, we want the forests to remain forests. If we are talking about biodiversity, we need to understand that 80% of Earth's land, animals and plants, they live in forests. If we are talking about carbon storage, the forest is a very important storage system for carbon. And everybody knows how important it is to talk about carbon storage nowadays. Water. Water is a must for us as live beings. The forests supply 75% of fresh water. If we are talking about products and energy, we are talking about the most important source of renewable energy. If we are talking about people, and we cannot talk about forest without talking about people. If we are talking about people, we need to understand that local communities are around the forests, that we have 14 million workers globally working in forest products industry. Next. Lots of companies and associations have just started to develop procurement policies to assure that the wood is supplied by certified and sustainable and legal sources. And PFC is one of the most important if not the most important third-party certification system in the world. Next. In Brazil, since 2022, PFC has been represented by an organization named Instituto Pro Manejo Florestal, also known as IPMF. It's a new start for PFC in Brazil, and it's a pleasure to be here representing PFC Brazil as Executive Director and introducing you to this new world of certified timber in construction. Next. Thank you very much. And here you have our contacts. If you have any doubts and more questions, please don't hesitate to contact us. To organize this, we counted with some partners. One of those partners is IBA, Indústria Brasileira de Florestas, and the other one is Núcleo da Madeira. We have here Thomas, that is member of Núcleo da Madeira, also known as Wood Technology Reference Center, since 2023. He has large experience of more than 25 years in projects, construction, and technical work. With master degree in urban planning, focused on sustainability, he has gotten a specialization in wood architecture, design, and technology. It's a pleasure to invite Thomas to introduce you to Núcleo da Madeira. Thomas, welcome.
Hello, everyone. Do you hear me well? Good morning. Do you hear me well?
Yes.
Okay. Can we put on the presentation, please? Yes, that's right. Thank you. So thank you, Adriano Nozella, for inviting us and hosting this event. Thank you, Pablo. We look forward to hearing from you. And thank you, IBA. This is where I'm sitting right now. So I speak on behalf of Núcleo da Madeira, which is a non-profit association founded in 2017. It's Núcleo de Referência em Tecnologia da Madeira. In Portuguese, it's Reference Center for Wood Technology. And we promote efficient and sustainable supply chain for wood construction. The idea is to integrate sustainably managed forests for a viable change for local timber cultivation. So to expand education and responsible use of consumption of products of managed forests. Next slide, please. So our mission is to encourage and disseminate sustainable technological and industrialized use of wood in construction processes and be a reference to it, to promote and encourage intensive use of wood in a noble way for construction buildings, promote wood towards a lower environmental impact, and deconstruct prejudice and stigma still very attached to it in Brazil, to encourage and minimize the effects in climate change and promote environmental education, as well as to provide technological and conceptual support for the wood construction supply chain. Next. So basically what we do, we advocate for the use of wood in construction from sustainably managed forests. We promote and demonstrate the viability of intensive, sustainable and noble use of wood in construction. We support industrial processes that make wood one of the most versatile materials. We demonstrate the contemporary nature of wood, and we strive to establish a sustainable supply chain for wood. Next. Next, please. Yes, and we're basically focused, no, previous one, please. We skipped. Yes, we basically focused on 5 axes: forests, components, education, design, and market. And last, next, please. And maybe, no, the previous ones, please. Yes. And we are happy to say that we hosted an international event from which we are developing a text. We'll go to COP30 that talks about the future of timber in construction worldwide. We had very important people that deal with timber and construction, such as Eric Koch, who works with Michael Green in one of the tallest buildings in the world. We have people from Japan like Tezuka Takaharu, who's worldwide known for his works, people from Chile, from France, from various countries. And from this final result, we hopefully wish to promote wood construction in Brazil. And then I leave you the stage to Pablo. Thank you very much.
Thank you, Thomas. And it's worth to mention that it was a great pleasure for PFC Brazil and to lots of architects and engineers and everybody. And now I'd like to introduce you to our keynote speaker, Dr. Pablo van der Lugt. Dr. Pablo is an architectural engineer and senior consultant specialized in mass timber and bio-based construction. After completing his PhD at Delft University of Technology on the environmental impact of engineered bio-based materials, he has combined consultancy and academic work on sustainability and circularity in the building environment. He is the author of several influential books, including Tomorrow's Timber and Booming Bamboo, and a high-demanded keynote speaker. Dr. Pablo, the floor is yours.
Thank you very much, Adriana. And what a pleasure to be here in Netherlands and be able to share my insights, mostly from Europe, to the other part of the ocean. So let me share my screen. Right. Do you see my screen? And also, do you see my pointer? That is good to know. Yes, well, I don't hear anyone, so I hope it's fine. Otherwise, just interrupt because I'm going to use the pointer. And by the way, if you have questions, my lecture will be almost an hour, and at the end there will be plenty of time for question and answers. Just put them in the chat, and then Evelyn and Adriana can help sort out the most urgent questions. Anyhow, it's a big pleasure to be able to present my latest findings. And again, it's also made possible through the support of sustainable forestry, through schemes such as PEFC. So I'm very grateful for that. As Adriana mentioned, I've written a couple of books and I like alliterations. So Tomorrow's Timber, Booming Bamboo. It was hard to find an alliteration in Spanish, but and Portuguese. That's on my wish list. But it's good to know for you that if you're interested, the book is also available in Spanish. So what I will be talking about in about an hour, if you really want to go into details and more background and scientific references, then well, try to get a hold of a copy of the book. Today, we're going to talk about the historic evolution of timber. Where did we come from and how did we end up making high-rise buildings out of timber? The why. Why should we build in timber? What are the benefits? But also, what are the challenges? Because it is a completely different way of building than that we're used to. So in the coming hour, I hope you will learn more about it. So beginning from the start, and again, I'm talking a little bit from a European perspective, so bear with me. But I think it applies to the whole of the world. In the past, we used a lot more of local materials, and most of those local materials were woods, but also bamboo, reeds that were grown locally. And we still see the heritage of the use of renewable materials, including timber, all over the world in our ancient buildings. In Europe, for example, we have churches of over 1,000 years old, just made out of timber. Many of our historic houses in medieval city centers are made out of timber, largely made out of timber, inside and out. And this is one of the oldest buildings I know of in Japan. It's more than 1,500 years old. And it also shows that if you construct well, then also timber can be very durable, can survive for a very long time. Look at this particular design. It's quite simple. You just have the overhangs. You make sure that the timber remains dry. And even if it's temporarily gets wet, it's not a problem because it can ventilate and dry again. And then also timber can be an endless material in terms of lifespan. But then came the Industrial Revolution. So in the past, we used to build a lot more with timber and renewable materials. And then the Industrial Revolution came. And timber, which is of course a kind of irregular material, was largely substituted by bricks, by iron, later steel, and concrete later. And that makes sense because these materials are very stable in their technical performance. At that time, timber was not. So since the 1900s, there has been more standardization in timber construction through the development of glulam, large glue laminated beams, and the development of all kinds of panel materials, MDF, particle board, OSB. But since 2000, something interesting is happening, and the use of timber is increasing. And that is because of the development of mass timber products. Because if we have the timber source, of course, from a sustainably managed forest with a PEFC certification, then we can do a lot of things with this resource because it will grow back. So part will go to the paper industry. Maybe a part will go to the energy industry. I hope as little as possible because the CO2 will be emitted again. But a large part will be used through stranding, through peeling, or just through sawing in a whole assortment of timber products. And the latest generation of timber products, like cross-laminated timber, CLT, glue laminated timber, but also, for example, laminated veneer lumber, I'll explain more about it later, enables timber to be used also in high-rise buildings and with very also good technical performance, such as the non-renewable materials it can substitute, such as concrete and steel and brick. And it gives a lot more opportunities actually. As timber is 5 times lighter compared to concrete, you can make incredible designs based on parametric modeling. Look, this is the Swatch headquarters in Switzerland. Look at this guy, how small he is. So these are huge elements and they are all pre-manufactured in a factory based on CNC milling. And every piece fits into each other like a jigsaw puzzle. So this is the inside. So it's curved, but every element is almost fitting into its place with millimeter precision. So because it's so light, you can also make huge spans and make fantastic architecture. But you can also go, Thomas already mentioned it, Michael Green is one of my favorite architects. This is not his building, but he also designs skyscrapers out of timber. And well, we can also with mass timber products go up to almost 100 meters high. Up to now, this is the tallest timber building we have in the world, which is completely made out of timber. There are higher ones, but they are hybrids. They have a concrete core. And this project in Norway, it's fascinating because it uses timber at outside, thermally modified cladding, but also at inside. I go one step back again, and here you see the glue laminated columns and beams. Here you see CLT flooring, and walls, and at outside the thermally modified, locally sourced pine. This is another timber skyscraper, 80 meters tall, 80. It's in Sweden, and it also shows the many prefabrication possibilities of building in timber. Because it's so light and so workable, you can make all 2D elements or even 3D elements completely in the factory. You put them on the back of a truck, and then you can build a lot quicker. Sometimes even the sanitary units and the kitchens are already installed. I like this building, Sarah Kulturhuis. It's a hotel and conference center. It's magnificent, right? And it's all locally sourced, made of PEFC certified locally sourced timber. But even the elevator shafts are made out of pine, locally sourced pine. So here all the concrete is replaced by CLT, cross-laminated timber. And also at the inside you see timber. And I think you all know people love timber because of the aesthetics, because of the tactile aspects, because of the odor, but also because of the sounds. Look around you. When you go to a music theater, you'll almost always see a lot of timber around you. So people relate to timber, but they're also often very worried about using timber because they know that the tree has grown for this. And this is why it's so important that you only source timber when it's sustainably managed. And that's why it's so important to have these sustainable forestry hallmarks, such as PEFC and also FSC. So let's go to Netherlands, because now we also have a skyscraper in timber in Netherlands. This is Amsterdam, and we go to the Amstel River. You see this building and you think from the outside, well, that's just an ordinary concrete and steel building. But don't be mistaken, because this is largely made out of CLT. So this is the picture of the building. It's really high end. And yes, it still has a concrete core, but all the floors and structural walls are made out of CLT. And then it's covered, of course, with a whole skin of glass. Timber is left inside, and many people love it. They don't want everything in timber, but when, for example, instead of the floor, the ceiling is in timber, or one or two of the walls, they love it. And it can also be high-end. So this is not just for tree huggers or ecological purists. It is also for the mainstream people. In South America, of course, you're still starting with the mass timber revolution, and I try to find a couple of projects with PEFC certified timber. So this is one of the ones that I found with the help of the PEFC Brazil team. It's the Dengo concept store. And what I like of this building is that, okay, of course, all the timber is left inside, but as I understand, this is made from locally sourced timber. It's one of a local pioneering CLT factory. So I like it, of course. If you can use the timber which grows locally, that's always better, of course, in terms of transport. So this is very nice. Here you have Brazilian CLT. And correct me if I'm wrong later in the Q&A, but for me, this is very cool to see. So how is CLT made? This is a German factory. And look, it's just spruce. And it goes to a laser eye. And this laser eye is very important because it detects if there are defects or knots or other weak points in the timber. Then the weak points are taken out, and then you have the finger joint that you see there. So what you see on the top and bottom of CLT is almost faultless strong boards. And then the lower quality boards can go in the middle. I have a piece here. It's always an odd number of layers you have, 5, 7, 9 layers. And then all the processing happens in the factory. So the milling for your electricity or for your fittings or for your window openings or door openings, everything is done in the factory. You saw some glue application. Many people are worried about the glue, but there's only 1% of glue in such a piece of CLT. So that's very little, and it doesn't restrict recycling possibilities. So when these pieces are ready, they can go on the back of a truck, and they can be transported to the building site. So, and I make the comparison with IKEA. It's like an IKEA cupboard, but here it's 10 times bigger or 100 times bigger. And in this case, it does fit. It's easy to make. So what you see here is this is not a building site, it's an assembly site, because you can construct a lot faster when you use mass timber elements. So let's zoom in on this building. This building is in, well, you can get it now, in London. And let's zoom in around it, because from the outside, it looks like an ordinary brick building. Like with the building in Amsterdam called Hout, this building, Dalston Works. From the outside, you could say, well, it's an ordinary timber building or brick building, but it's not. Don't be fooled, because it looks like brick. And also at the inside, you wouldn't see there's timber. I think it's a pity, but doesn't matter. For carbon storage benefits, it's still a very good idea. But then, if you look at the inside, it's all made out of CLT. And for this product, they chose timber from sustainability reasons, but also for logistical reasons. Because, as I explained, timber is 5 times lighter than concrete. This means you can work on tight building sites in the middle of the city center with a lot less nuisance, because you can build so much quicker. You can use smaller cranes. You need a smaller building site. And in total, instead of 700 concrete truckloads, you just need 100 timber loads, because timber is 5 times lighter. You can also stack a lot more of timber on one truck. And then you get to the building site, and then it goes incredibly quick. It's 9 months faster, this building, compared to in situ cast concrete. So think about that. You have less noise, less people on the building site, and you can also deliver a lot quicker. They made a cost comparison for such kind of apartment buildings in concrete and in CLT. The foundation can, because the building is lighter, also the foundation can be lighter. It's still concrete foundation, but you can have a less heavy concrete foundation. So you save some money there. Above ground, timber is still a little bit more expensive, and also CLT, so you will pay a little bit more. But then if you take into account that you build a lot quicker and that you get your rental incomes, because this was made for a developer 1 year earlier, then the business case becomes very close to cost neutral. So the main contractor items, for example, are lower for a CLT building than a concrete building. So in total, maybe a little bit more expensive, but if you think of the benefits and also the CO2 benefits, which I touch upon later, I think we are soon coming to a break-even point. So I just showed you now CLT building, but let's also show you another important mass timber product. That's LVL. LVL is made of peeling a complete roundwood stem. So I'll show you how this goes. So you have those roundwood logs. They're cut to pieces. And then look how much of this whole roundwood is used. Look at this. This is fascinating to me. It will be peeled almost to the end here. So you have the whole log, it all goes in an automatic way, and almost the complete log is processed into sheets, veneer sheets. Then these veneer sheets also checked on defects. The poor parts are taken out, then dried, and then in the end, and I'll go a little bit further, it will be pressed to each other. This product uses a little bit more glue, about 3 to 5% of the material dry weight is glue. And then you have these very strong elements that you can use as a panel, but you can also use it to make very strong, really very strong beams. For this, you can make very long spans. So this is an example. These elements are called cassette flooring, and you can make spans up to 10-15 meters with this laminate veneer lumber, LVL technology. So this is an architectural office in the Netherlands, which is made using these cassette floorings based of LVL. And in the end, I think I'm very small, but here I have a piece. You see the little layers that it is made of. But this is also interesting building, designed by one of the, let's say, the Michael Green from Europe, Andrew Wall. The black and white building, it was recently opened. And it's made with LVL, but special LVL. Because typically LVL is made from spruce or pine, but this one is made out of beech. Because of climate change, we see that deciduous trees are coming more up north in Europe, and beech and oak become a little bit more the dominant species. So this manufacturer makes LVL from beech, and beech is a little bit stronger than pine. So this means that the beams can even be more thin than they would have been made in glue laminated timber. And long spans again. So this is a very interesting project showing that also other tree species besides the often used coniferous species can be used for mass timber products. So that's a picture on the inside. So I hope I showed you a little bit what are the developments. In a second, at the end, I also show you some bigger developments, neighborhood developments. But you see, there's a lot of things happening in Europe. And why is this happening? Why do these kind of architects like Michael Green and like Andrew Wall, why do they choose wood? Well, for very clear reasons. One, obviously, climate change. If we look at the built environment, almost 40% is related to it. Of this 37%, 2/3 is related to the operational energy use of our buildings. But 1/3 is related to the embodied carbon, so the CO2 emissions during the production of building materials. If we look at the CO2 emissions just of the concrete and cement sector, it's responsible for 8% of our global CO2 emissions. Steel, aluminum, plastics, almost the same. So to put this in perspective, for example, Brazil, or no, the whole continent of Latin America emits 6%. So just the concrete industry emits more CO2 than the whole Latin American continent. Think about that. Why isn't timber here? Well, one of the important reasons is that it will emit very few CO2 emissions during production, which I'll show more. But the big benefit is that with every plant or tree, it absorbs CO2 during growth through photosynthesis. So if you have the CO2, it's the carbon is absorbed through glucose in cellulose and hemicellulose, and the oxygen is released again. So if we look at 1 cubic meter of timber, pine wood in this case, then half of it is carbon, and the carbon used to be CO2. With the O2, we breathe again. So 1 cubic meter of pine during growth has absorbed almost 1 ton of CO2. So if we then start to burn the wood again, then the CO2 is emitted again. So that's not a good idea. It's a lot better to store this carbon in buildings. And then many people say, okay, that might be interesting, but looking at the factories and the glue and maybe the sourcing of the wood and the transport, doesn't this emit a lot more CO2 than is being absorbed? Well, the answer is no. This is the life cycle assessment result for the CO2 of this factory, which I showed you. It's the factory of Derix in Germany. In 1 cubic meter, almost 800 kilograms of CO2 is stored. The light green circles show how much CO2 is emitted. So you see the glue is only 90 kilograms of CO2. Other raw materials, transport to the building site. In total, the CO2 emissions are just about 1/8 of the carbon stored. So as long as timber and CLT is in use, you can really say you are storing carbon in the built environment. And now comes the interesting part. And here also comes the counterplay with sustainable forestry. Because if we make it very simple, and this, I know this is super simplified, but this in essence is what's happening. If you plant a new tree in a sustainable managed forest, it will grow, it will absorb CO2. At some point, it will be mature. Depends a bit on the tree species, can be 50 years, can be 80 years. At that time, you come to a kind of CO2 equilibrium, and it's a good moment to harvest the tree and then not burn it for energy production, but use it in the built environment, because then the built environment becomes a carbon store. After you plant then the trees again, so this is what sustainable forestry is about. Then you'll harvest again. And then here you see in total, there's a kind of constant amount of carbon stored in the forest. This is carbon pool 1. But here comes carbon pool 2. That's the carbon stored in the built environment, and you can add them up. Then, if we don't start just building little houses out of timber, but if we start replacing big buildings, which normally would be built in concrete and steel, with timber, then you also have to avoid CO2 emissions. So a building, and I looked for another timber project in Latin America. I came across this fascinating building. It's a shopping center, La Zarzuela in Cartagena in Colombia. And it was a former bullfight place. It was destroyed and it was rebuilt, completely made out of timber, mass timber. Well, I haven't been there, but I really look forward to see this because it looks great. And in this building, they did use PEFC certified timber. In this case, it came from France, prefabricated and then built very quickly on site. But if you imagine this building as a case study, it uses about 600 cubic meters of pine. Then there are all kinds of calculators, and I will share the PDF of my presentation later that you can do online, where you put in the amount of cubic meters of timber, and then it will calculate how much carbon is stored in such a structure. I'll do this for the Cartagena shopping center, but also taking into account that normally these kind of shopping centers would be built in concrete and steel and brick. So if you look at the CO2 emissions of these materials, well, this is a very interesting graph, the CO2 pyramid. You see that per cubic meter of material, aluminium has the most CO2 emissions. Here is steel, here is concrete, here is PVC, and here is, for example, CLT. So imagine we store carbon in CLT, but if we also start to substitute concrete and steel, then we also avoid the CO2 emissions of these kind of materials. And as a very rough rule of thumb, you can say when you use 1 ton of softwood sustainably sourced with a PEFC label, instead of concrete and steel, you also avoid 1/2 ton of CO2 emissions. This sounds maybe a little bit complicated, but it's not. So let's take the Cartagena shopping center. And you see here that it uses, as I said, almost 600 cubic meters of glulam. This will store almost 500 tons of CO2 for the lifetime, but it will also avoid over 500 tons of CO2 emission, because typically this kind of building shopping center would be built in concrete and steel. So in total, the CO2 benefit is 1,000 tons of CO2. And I checked, that's about as much as 435 Brazilians emit in a year, just by building in timber. So imagine if we would build all our buildings in timber, what would be the benefit then? So let's look at that. What would happen? And there is a very interesting meta study. What would happen if we make our new big buildings and also hotels and restaurants and office buildings in timber? This meta study was published in Nature, a very respected journal, a scientific journal, and it models 2 scenarios. One, business as usual. We keep everything as it is. For scenario 2, we start building a lot more in timber and try to reduce CO2 emissions and capture CO2 in the built environment. What is the difference in CO2 emissions between business as usual, 10% in wood, or 90% in wood? Well, this is the 10% in wood scenario. You see a lot of CO2 emissions by the construction embodied carbon of steel and concrete, and low CO2 emissions with the production of timber, and actually a larger carbon store, as I explained, in the wood itself. Then 90% in wood. Well, then you see this is the avoided CO2 emissions that I just talked about. You don't have those emissions anymore of concrete and steel. And the carbon store is a lot bigger in the built environment. So the difference between scenario 1 and 2 is 100 gigatons. Maybe it doesn't tell you a lot, but 100 gigatons is enough to compensate 25% of our carbon budget to stay within 1.5 degree temperature rise. So 25% of our carbon budget can be saved if we start building far more in timber. So that's clear, right? That's a big benefit, the climate problem reduction when we build in timber. Then another one, resource scarcity. Also here, the built environment, of course, is connected to a big consumption of raw materials. Almost half of raw materials are used in the built environment. Well, this is what our city centers worldwide look like. This is Sao Paulo. Only concrete, only steel, only glass. That's all we see. We hardly see any timber. And at some point, we will see that these materials do not grow back and will be depleted. This is in particular the case for iron materials such as aluminium and iron and copper and zinc, but also increasingly for oil-based materials such as PVC or PUR for insulation. So this will be an issue going forward. But many people are more worried about wood than about bricks and iron. Because, as I explained before, we care about timber. But to give you a little bit of perspective, to give you an idea, I showed you, and I'm going to talk about the European forestry industry, which I know most about. So maybe interesting to also see how this is organized in Latin America and South America and Brazil. But if we look at the European forestry industry, 600 cubic meters of pine sourced in France is used in this building. So think about it. How long do you think the European forestry industry will take to produce these almost 600 cubic meters of timber for Cerezuela shopping center? Just give it some thought. What do you think? If you have any idea? The answer might surprise you because it's less than 4 minutes. So as long as I now have been talking, about 8 or 9 Cerezuela shopping centers have been produced based on sustainable forestry in Europe. So it's like a motor, it grows back as long as it is sustainably sourced. So when people ask me this question, I usually ask them a question back. I ask them, where do you grow your brick, your rock wool, your PUR, your concrete? Because these materials, they don't grow back, but people have no association with them whatsoever. They just see it as a neutral material which does its job, and they don't care about it. So why does this worry come from about using timber? It's this. It's about deforestation happening worldwide. And as you know, of course, also a lot in South America. It is reducing the deforestation rate the last 30 years, but it, of course, still is a big problem. And of course, you also know that one of the main drivers of tropical deforestation is not demand for timber, but it's on land conversion to produce cattle land, or for commercial agriculture to produce palm oil or soy to feed our cattle, subsistence agriculture. And ironically, quite some deforestation is also caused by mining, or for aluminium, bauxite for aluminium. These are also important drivers for tropical deforestation. So this is why it is so important to have chain of custody sustainable forestry schemes, because this will make sure, and Adriana also already mentioned it, that forests remain forests and no more timber is harvested than is regrown in the forest itself. And I go very quick through this. There are two main schemes. PEFC is bigger, focuses a little bit more on coniferous trees. FSC is a little bit more dominant in tropical areas, but of course they both do a very good job in securing the whole chain of custody, making sure that the timber that you use in your building project, in the end, over every part in the chain, meets people, social, planet, environmental, and profit and economical requirements. And of course, most of the requirements are focused on the forest itself. I know PEFC quite well, and just look at the certification requirements. It's huge documents with requirements that you have to maintain about biodiversity, about the involvement of indigenous people, about the water table that has to stay intact, about the carbon storage. And all of this is covered from the beginning in the forest to the final product in the building site. So I think this is a great benefit that timber has compared to other materials. And what's also very nice is that if you use it, and I'll have some exemplary projects later on, then you can also get, with a PEFC certificate, you can get extra credits for schemes such as green building schemes such as LEED and BREEAM. I don't know if you noticed when you looked at this map, but in the northern hemisphere, you see that the forest area is actually growing. And this doesn't look nice in Europe, but it's set to increase again because of the big green deals that are signed in the EU. But still, in total, there's more trees planted than are harvested. So let's zoom in on this a little bit closer. In the European Union, you have 180 million hectares of forest. This grows with 0.3 million hectares a year. Doesn't sound like a lot, but this is 500,000 soccer pitches a year, which is added every year again with forest. And most of this forest is certified, PEFC or FSC. And if you look how much timber is harvested in these forests, it's only 500 million cubic meters. The annual increment is about 800 million cubic meters. So that means every year there's 300 million cubic meters extra on roundwood that is grown in the European forest. On the short term, you cannot reach all this surplus biomass. But with about 5 to 10 years, the Wageningen Forestry University has calculated that you can easily, in a sustainable way, harvest 50 to 100 million cubic meters extra. So let's see how much it is. So let's make a conservative assumption. That's only 50 million cubic meters extra. 15 million cubic meters extra. And by the way, this is the forest map of Europe. So 40% of Europe is forest. So this additional capacity in Europe is 50 million cubic meters. So going from roundwood to, for example, CLT, there's a conversion loss of 50%. Well, these residual streams are used for products such as OSB or, for example, MDF. That means that you have still 25 million cubic meters of timber, mass timber. One private house will use 50 cubic meters. An apartment building will use 25 cubic meters. So this means, based on the annual additional capacity, you could build 500,000 houses or 1 million apartments each year extra based on the additional capacity. Well, in Europe, the demand for housing is 2 million apartments. So this shows that we can do a lot more in timber. I think from the 10% it is now, we can easily scale up to about 50% in timber with all the CO2 benefits. And if we talk about renewability and the problem of scarcity, you have the renewability in the forest, but if you design for disassembly, then in the end of life, you can also harvest materials from buildings that are being demolished, or let's call it dismantled. And this is so nice of timber because most of the connections are in a dry manner. So they're just bolted or screwed together. So that means you can also unbolt or unscrew them. So I show you another building, which from the outside might seem not that much made out of timber. But if you look at the inside, the full structure is made out of glulam, columns and beams. And this is an interesting material because these are hollow floors, kind of cassette flooring, what I mentioned, but they also include the sound insulation. So when you see this building site, most of the buildings are, you see very few people on site. And here you see it's really made like a Lego system. The elements come on the building site and they're just bolted and screwed together. You need very little people on the building site. You need small cranes only. You can build a lot quicker also here. And these are the cassette flooring system I was talking about. And everything is put on top of each other. So you can just unbolt it and unscrew it, and you have those elements available again. Now, the final building is really beautiful, and the people working in it really love it. Compared to the previous building they worked in, which was in steel and concrete, the absence percentage has reduced by about 2%. So think about that. Your laborers love to work in the timber building, but it's also very demountable and circular. And to give you another case study from the Netherlands, in Amsterdam, there in the central business district of Amsterdam, this little building is being demolished. You see it here. It's made for the bank ABN AMRO, and it was made 10 years ago to be the most circular, let's say, dismountable pavilion or building available. And it was set to be used for 100 years. But then the soil was sold to another investor who wanted to build a bigger timber building there. So now the proof is in the pudding. And this building, which is designed for disassembly, from the start had to be deconstructed. This is the building site. I made these with my own telephone. And here you see that the whole building is dismounted. And it's just reverse engineering. You hear the guys, they're working on the screws. And this is it. It's very simple. It's reverse engineering. And then those elements were put, they were labeled, which you see here. They were put on the back of a truck. And they're completely suitable for reuse. So they're now in a warehouse. And there's a tender process going on. Which developer wants to buy these elements? And I can tell you, they just go for the normal price. So this shows you that you can build in a dismountable way, that the theory actually also works in practice. So if you start designing for disassembly, for mass timber is very suitable for that. So you can get timber from the forest, yes, but you can also harvest timber from building projects that are being demolished. And this is the next building that will be constructed there, also in timber. So if you design well, then the first life of a timber building can be 100 years, 200 years, or longer. If you design for disassembly, which I just showed, then you have a second long life of timber, maybe again 100, 200 years. Only then, if the timber, the quality is not good enough anymore, then you can make particle board out of it and use it, for example, for the furniture industry or for timber frame housing. And only in the fourth or fifth life, then should you burn the biomass for energy. And in the meantime, the forest will have grown back, if it's sustainably managed, 5 to 10 times. So I always call timber double circular, because you can reuse it, but it also regrows. So for the final part, I want to give you some points of attention. You're most engineers and architects, and when you design and build with mass timber is completely different than traditional building. So it has some challenges, but you just have to know about it. So one, acoustics. Well, as timber is 5 times lighter, usually depending on the timber species, but most pine is 5 times lighter to concrete. This means that especially for footfall, vibrations will be transferred more easily. And for airborne transmissions, well, this can be solved quite easily. You just have to use elastomers and you have to make sure that you use the cavities. So the airborne insulation is not too difficult, but the more challenging is the footfall, the vibrations that can go from one apartment to the other one. So usually you have to add mass on top of a CLT floor, structural floor. So I go back to the case study in Amsterdam, Hout, because this building uses a system which combines CLT with a top layer of concrete to give the mass. And because of this, the footfall is not a problem anymore. So this also explains why you still see the CLT in the walls and the ceiling, but not on the floor, because they put the concrete screed floor on top. What I don't like about this system, it's not too circular, because in end of life, if you want to dismantle it, then you have this element made out of CLT and concrete, which is connected with anchors, and you cannot, in a clean way, split them and divide them again. So a new system works like this. You put all the installation on top of the CLT floor, then you put a wet guard, so you mean a non-permeable foil to make sure that the CLT doesn't get wet in case of leakage. And then you add gravel or sand on top of it. So this is another example where gravel is put in, and of course you can imagine that you can very easily take the gravel out in end of life because it is not connected to the CLT. Then you of course put the finishing layer and finishing floor, and you are ready to have a very nice apartment building meeting all acoustic requirements. So this is of course in a nutshell, it's far more complicated than this, but it gives you a little bit of an idea. For acoustics, it is challenging, but you can solve it. And actually the same applies in terms of fire safety. What I show you here are remember the tallest timber building in the world, Mjøsternet in Norway. Very tall building, I showed in the beginning. They had to do one-on-one tests to make sure that this building got the fire permit to be 120 minutes safe. So they did that by over-dimensioning the timber. If you don't want to do this, because maybe it's a little bit costly, you can always encapsulate the timber and put gypsum fire-rated board on top of it. But then you don't have the health benefits. You don't see this timber anymore. So I think it's a pity. So I prefer a lot more that you a little bit slightly over-dimension the timber. You can imagine if you have a big piece of wood, and also this also applies to CLT. If you try to put this in the fireplace, you can imagine that at some point it will char and at the outside it will get dark. But behind this charring layer, the timber remains structurally intact. And we know exactly how quick this charring goes. It's 0.7 millimeter per minute. So if you over-dimension, for example, with 4.2 centimeters, you have 60 minutes of fire safety. So these are the one-on-one tests I was talking about for the tallest timber building in Norway. So this is another tall timber building in Rotterdam, which was just opened. And here, 3 fire safety measures are combined. That I managed to do 2. So this is 1, finish with a fire-rated gypsum board. 2, over-dimensioning. And number 3, but it's a little bit more costly, is adding a sprinkler system. You don't have to do this for this building. They wanted this just for the feeling of safety, because also in Netherlands, mass timber buildings are quite new. But why I really like to keep the timber inside is because it gives a lot of health benefits. And this fits with the principle of biophilic design. There's a lot of research done which shows that people, when they are in a building with a lot of daylight, with a lot of plants and a lot of visible natural materials, and sometimes also even organic forms, perform better, have a higher feeling of well-being. What you see here is not a coincidence. It's a cancer healing center in the UK. And we see an increasing amount of evidence which shows that people that work, live, or are educated in timber building just perform better. This is another of those cancer revitalization centers. This is a school. And also for schools, there was a very interesting study in Switzerland which showed that pupils that were followed for 1 year in a timber building compared to a plastered building, classroom, had lower heartbeats, higher concentration, and better overall grades and performance. So people like to live and work and stay in a timber building. Imagine offices that are finished with plants and a lot of timber. This is a big survey done in Australia, showing that people working in a timber building had better performance and better concentration and just felt better. Think of the value of that before looking just at the costs. Because of this, and I mentioned this, there are many green building certification schemes such as BREEAM and LEED, and one which only focuses on well-being is called WELL, W-E-L-L. And you see that also here, timber scores very well. And that partly comes from the PEFC certification, but it also comes because of the low carbon emissions and the health benefits of it. So the highest scoring BREEAM building worldwide is in the Netherlands, almost a perfect score, and it's completely made out of double laminated timber. Then you see also many LEED certified buildings on the highest levels, platinum or gold, which are made out of timber. And the same applies for the well-being standard WELL, with several high scores possible, the WELL Platinum Award for various timber buildings. So if I briefly look at the future, I already showed you that a lot is happening, at least in Europe, a lot is happening, and it's going to continue. Because we see bigger buildings, we see bigger developments, we see all skyscrapers announced over 100 meters tall in timber all over the world. But what I find most exciting is that instead of just separate buildings, I see now whole neighborhoods being announced and developed in timber. And I can also show you hundreds of those, but the biggest one, which was announced about 2 years ago, is in Stockholm, in Sweden. It's the Wood City. It's a former brownfield, which is going to be turned in a complete neighborhood made out of mass timber. Very nature inclusive, as you can see, using having 7,000 offices and 2,000 houses. And the construction has started. So this development should be ready in a couple of years. And we will have our first completely timber city. So sometimes when people ask me, why wood? Actually, again here, I would turn the question around. Why wouldn't you? Thanks for the attention. And now let's bring it back to Adriana and Evelyn for maybe some Q&As. I hope you could follow it. And again, if you're interested, there is a Spanish version of my book available. Thanks.
Thank you very much, Dr. Pablo. And I'd like to reinforce that our Q&A chat is open for your questions. We have already some questions that Evelyn will bring to you, Dr. Pablo.
Thank you very much.
Hello, everyone. I'm Evelyn, Technical Manager at PEFC Brazil. Thank you very much for joining us today. And Dr. Pablo, thank you very much for your meaningful presentation. We do have some questions here. First one is from Jean Nicolau, which is our chair from PFC Brazil board and also works for Núcleo da Madeira. He says, in Brazil, there's a lot of prejudice against wooden construction, even among engineers and architects. Do you also face this in Europe, or how did you deal with it?
Very good question. Yes, we also have this problem in Europe. This is why also we developed the Tomorrow Timber Talks. That I think in Europe I have visited hundreds, maybe more architectural offices, and everywhere you get the same questions about, well, when we start to build a lot with timber, then our forest will be gone, or is it fire safe, or won't timber rot away very quick? So there's a lot of prejudice. And think about already the story tell with the wolf and the three piglets. It starts, of course, always with the smartest pig lives in a brick house, and the timber is very weak. But so we start from the outside with the timber construction industry lagging behind. And one of the other things we did together with, for example, Built by Nature, the organization, is I wrote a free book. You can also, by the way, download this for free, discussing timber myths. And here, many of those myths are dispelled. And it's very important that we do a lot of communication. We do a lot of presentations. We do a lot of information booklets, because we are just lagging behind in terms of perception of many people that think concrete is better and it's more sustainable and will last longer, but people don't have the complete information. So also in Netherlands, which is actually traditionally a brick country, we still a lot of lack of knowledge. So we have to keep reinforce it and give the right information to the prescribers, to the architects, to the municipalities, because when they learn that actually timber from a sustainable managed forest with a PFC or FSC certificate captures more CO2 than it emits. It's part of the solution instead of part of the problem. Sorry, I just closed the window here. Yes, I'm back. So I hope that answers a little bit the question, but yeah, keep promoting, and also policymakers have to be convinced. So for example, the COP30 will be very important. There is a pledge for the use of sustainable woods in construction, and various countries have already signed it, and it will be a big thing at COP30. And I think it will be important also that policymakers start viewing how important it is to build in timber based when making sure that it's coming from certified forest.
Thank you very much. Next question would be, all the examples we see of large wooden construction are always made with soft wood, mainly conifers. Question: are there examples of tropical hardwood being used in this type of construction? Would it be possible to develop products from tropical hardwood?
Yeah, good question. It's possible. And that's why I also showed the example of Bouwbugge, the beech, which is a deciduous, it's actually a hardwood species, a European hardwood species. So it is possible. And for example, Andrew Wall has done a lot of testing also with tulip wood, which is another wood species. I think it's also a very light hardwood. But you have to imagine if you want to make, so it is possible. I mean, you can also have tropical hardwood and use it to produce these kind of panels. But imagine tropical hardwood is heavier, and maybe it's just too good to use for CLT. So, for example, I would more advocate the use of fast-growing radiata pine that grows in Uruguay, I think also in Brazil, to use CLT. Use those faster growing wood species that don't have the high durability because you don't need it. So Answer is yes, you can do it with tropical hardwood, but I would also discourage to do it because I think it's better to use fast-growing softwood species for CLT because you just will have more feedstock. And tropical hardwood is so good, you can use it, for example, for window frames, outdoor window frames, or decking, or cladding, or other applications, which complement the mass timber shell structure that you can use. That's in a nutshell how I would respond. So yes, possible, but think twice before using very good quality tropical hardwood for your CLT and glulam.
Thank you. Maybe we can invite Thomas, who also has a question for you.
Hello, Pablo. Thank you again. I have a question for you, which is in face of deforestation that replaces forests for cattle, soya plantations, and palm, giving added value to trees could be an effective alternative. And Brazil has at least 16,000 indigenous tree species, most of which hardwood, that could be technically used in wood for construction. We know that humanity doesn't know yet how to plant tropical forests with multiple varieties of indigenous trees yet. This is being developed. But once this has been developed, and given these facts, do you think there is a potential for a forestry revolution? What are your comments on that, please?
Yeah, it's a very good point because in a lot of a little bit older primary or sustainably managed forest, you have a lot of different species. So I know and I acknowledge that I talk from a European perspective, where you see a lot of 2, 3, max 4 species production forests that are really made for to produce structural timber. So if you have forests that are that have such a big diversity of species, then it's also important, of course, to do the how do you say it, selective harvesting, so the forest remain forest. And each timber species has its specific qualities. So the very durable hardwood species, and I'm thinking of what are the names again of the, of course, Ipe is at this point a little bit difficult, or Kumaru, or there are many other new species that are coming up. They are very good to use for durable purposes. But for example, balsa is very light and can be used as insulation material. So every application requires different properties. So in terms to maintain a forest and give it a kind of economic value, it's important that each species is used for its application in which it has true added value. So this is what I also mean with CLT. Only use fast-growing species there because very good quality tropical hardwood. I mean, and of course there are many different things fall under tropical hardwood. I also acknowledge that. But assuming it's very durable tropical hardwood, then I wouldn't use that for CLT. And I also want to say one other thing. Some people say we have to build everything in CLT and glulam, but just timber frame housing is a more efficient way of building than CLT. So CLT is good if you want to make multi-story buildings in timber. But if we just want to have a single family house, then it makes more sense to use local materials. So that's also bamboo, but also locally grown madeiras that are just suitable and grow quick for those purposes. And then on the outside of the building, you choose the more durable species. So I think, yes, it's very important to look at every species available and give it, instead of using everything to produce energy for biomass or pulp for paper, try to give it its most value-added application, because then it will last longer, store more carbon, and indeed, you'll also give more value to the forester, and the forest can remain forest. I hope that addresses your question, Thomas, because
it does. But it's another reason for you to come to Brazil. I think we have a lot to exchange.
Yeah, it will be great. And I'm really I really acknowledge that I really talk from a European perspective. So that can be interesting because you get new insights, but some things are just different in Brazil, and also the species that you have and the problems and the deforestation and the pressure on the land for various reasons.
Absolutely.
Thank you. So another question. In Brazil, concrete and masonry are the predominant teaching method in architecture and engineering schools, which makes it difficult to prepare qualified professionals for wood design. What is the situation with architecture programs in Europe?
Yes, in Europe, I think it is really changing. I actually studied architecture at the Delft University, and there was no timber curriculum at all. That was about 20 years ago. And since 10 years, with the development of mass timber and several pioneering architects embracing it, we see that also big companies, big developers, big contractors, big engineering firms like Sweco are also embracing timber. This means education is also following. So since 2 years, we now, for example, in my own university, Delft, we have a timber chair. So a professor which is completely focused on timber construction. And the university has to, because the demand from all the students is about bio-based construction. They have heard about it, they have seen documentaries about it, they've seen many timber buildings, they love the architecture of it. So the demand comes from the students itself. And I know maybe you're still facing some kind of resistance there, and often those big industries like concrete industry, they finance these kind of universities. One thing what you can do, and maybe you can share later with the participants, is two things. Well, one, with PEFC Southeast Asia, we have developed an online course which people can follow, and you can share that. Basically, what we're doing right now, but then sharing it online. But we have something which is maybe even more interesting, and that's a massive open online course, MOOC, MOOC, with TU Delft. I maybe can even find it and put it in the chat, which is a free course for 8 weeks long, and that people all over the world can follow it. And this is something maybe also, yeah, you can help share in Brazil, because the enthusiasm has to come from the students in a new generation of architects itself. And when they keep demanding, I want a timber education, which is what happened in Europe, because many universities now have their own timber chair and timber curriculum. And I'll try to find the MOOC and put it in the...
Yeah, thank you very much. And this is so important that we have another related question about education. I'm a teacher from Brazil, and I wonder how can I get some samples of the system to show to my students? Is this a fellowship with industries?
Sorry, can you repeat it? I was trying to find, this shows that I'm very bad at multitasking, because I'm looking at the Q&A, and I'm trying to share but I think I cannot reach the chat. I cannot do anything in the chat. Okay, we have to share that later. Sorry, can you repeat it? I'll be fully focused.
Yes, of course. I'm a teacher from Brazil, and I wonder how can I get some samples of these systems to show to my students? Is this a fellowship with industries?
Yes, so it was relevant to share to share this link. This is actually why we developed at TU Delft this MOOC, the Massive Open Online Course, because this is the easiest and cheapest, because it's for free way to share a 6-week curriculum with many examples how you can build in timber. Yeah, and the next thing is just go visit timber projects like the Dengo Concept Store, and there are many timber projects, of course, all around Latin America, and maybe there's also an opportunity there for schemes, green building schemes, and Núcleo de Madeira and PEFC to share this information. In Europe, we have this organization called Built by Nature, which is an NGO, which really puts a lot of money in stimulating research and education and network about timber construction. And they're trying to expand also the coming years to other regions. And the CEO, Paul King, will also be attending COP30. So maybe it's also good for Build by Nature to put in, from any of your sides, a demand for help us. How can we accelerate the knowledge about timber construction in the curricula in Latin America? It's just not a one silver bullet answer. It's really very context specific, but at least this MOOC, Massive Open Online course, I'll share it after this with you all, with PFC Brazil, and then maybe you can share it with the participants.
Definitely. Thank you very much. Adriana.
Thank you, Evelyn. It's worth to mention that Built by Nature will be presenting the principles for responsible construction on COP30, and we will be together. We from PFC Brazil and PFC International will be together with them and IBA, that is our institutional partner for this webinar as well. And it will be on Wednesday, November 13th. We already have a date, so it's something strong and true that we'll be there together in Belém soon. So if you have opportunity to be there, please get in contact and try to listen what we will be sharing with you there. Otherwise, of course, we will share this after COP. Okay?
Great to hear that. Very important. Yeah.
Yeah, thank you. So another question would be, is wood a viable solution for mid and high-rise buildings in urban area with challenging climates? And I also would add on that regarding the economic viability.
And what do you mean with climate? With a difficult outdoor climate? What is the, does it say the question? Or is it financial
No.
climate?
Yeah, I believe, yes. I think so. It's not specified.
Well, in general, about mid and high-rise building in timber, I give some very beautiful examples in my presentation, but I sometimes wonder if it is the best application for mass timber, because if you go up to about 6 stories, then you need less timber and it is less difficult, the construction, compared to over 10 stories, because then it becomes more complicated. You need more timber. Sometimes you also need concrete. So in general, I think the business case for timber is better until about 6, 7 stories tall buildings. That's in general. If the climate is very challenging, and maybe the outdoor climate, and I am aware that maybe in Brazil you have termites and you have other challenges than we have in Europe. I think most of them can be solved, because in general, if you're building well, then the indoor shell or structure should not be reachable by any outdoor circumstances, by rain, by sun, by insects, by termites. If this is a big risk, then you can also impregnate the timber. This is done, for example, in Australia and in New Zealand. They have a termite problem there. And if, for example, for the ground floor you want to make work in CLT, then you can also impregnate the boards and then make your CLT panel. In that case, you also have termite-resistant CLT, let's say. So that is a little bit from both perspectives. For economic climate, I think I would recommend to stay below 10 stories, because then you can really compete economically. If you go higher, then for sure it will be quite an expensive building. So those big timber skyscrapers that I showed you, they are more expensive than a traditional timber building, maybe even 20-30%.
Thank you very much. Thomas would like to make another question. Please, Thomas.
Yes, Pablo. As I studied architecture and urbanism, and Holland is a fantastic source of information and culture, and thank you again. One of the things I've learned in the past, cities in Holland were built according to a special standard of the size of the tree trunk. So that's why you have many of the old buildings in width are very narrow, and you had very specific codes that you could build one after the other because one building would support the other. What I'm saying is, from a component and from an architectural point of view, you design the whole city, and you brought us so many technologies, so many novelties. How do you see the future of the urban landscape using timber?
So that's an intriguing question. Well, I think, as you saw in the example of the Wood City development during my presentation in Stockholm, and I couldn't share you more neighborhood developments. Ideally, first of all, you look at condensing cities more instead of building around the city. So in some, like Los Angeles is one big suburbia. I think that's a pity. I think it's better to condense your cities, and that means that on some places where you already have concrete buildings, you can top them up with one or two extra layers of timber. There are many examples of topping up projects all across Europe already. And then when you look around it in the direct environment, try to combine nature with the built environment. So as you saw in the Wood City development, you also saw there was a lot of gardens on top of the roof. So also the nature was included in the development of those timber constructions. So ideally, in the ideal situation, you will get carte blanche and first build and densify in a nice way the built environment that you already have, and also add vegetation layers. And in the stuff that you have to add, make sure that it's nature inclusive, and if possible, produced in an industrial way. So in Netherlands, we have a lot of factories. A lot of the big contractors have a housing factory. The modular 3D elements are being made, and they can be stacked on top of each other, giving still a lot of architectural freedom for the facade and for the variation, but they're produced in the factory. And in this way, and timber is very well suited for industrial production. In this way, you can produce a lot quicker, but also with a lot less CO2 emissions and still cost effective. So these three things, densification, nature inclusion, and industrial production of concept houses, of modular housing, these I think would really help in meeting housing deficit, but also for the people that have less budget. Because this way, with industrial production, you can still make nice houses and good quality, but at a lower price. And this is also very suitable for mass timber.
Well, this is a very inspiring forecast. Just to know, in Brazil, we have a housing deficit of 6 million dwellings.
Wow. Yeah, and I think maybe sometimes you also have to look, of course, and also know quite a lot about bamboo, and you have a lot of giant bamboo, of course, as well. Actually, I really encourage PEFC to also have the bamboo certified in the future, because that, of course, grows very quickly, grows locally, and can be a very nice addition. Also has the carbon sequestration benefits, and can be, in some cases, be a good complementary material next to timber. Also renewable, also carbon storing, and sometimes cheaper to make hybrid timber bamboo systems for housing, and also for, let's say, really the lower income part of the population.
Well, everybody, this is a very interesting and intriguing, subject. This is just the first of many other webinars we intend to bring to you. We have more questions on the Q&A chat. We promise we will get the answers and send you guys by email, but now it's time to finish. It's 10:31. So I'd like to thank you, everybody, mostly Dr. Pablo as our keynote speaker, but our partners, and of course, you, our attendees, and let's keep in touch. You have our emails, our contacts. Don't hesitate to send us messages that you want, and we will address to Dr. Pablo. Okay? Thank you very much.
Thank you. Bye-bye.
Bye-bye, everybody.
Thank you.